Good evening. This is VK7 OTC, the club station of the Radio and Electronics Association of Southern Tasmania, with our DATV Experimenters Nights. And we have a huge number of viewers on streaming, and welcome to all those viewers from around the world. And I suspect that's because of a special event which happened with the man who's sitting next to me, who I'll throw to in a minute, Rex VK7MO. With 2 world records in a week, so that's fantastic, Rex. So I will go across to Rex and congratulations.
Thank you. Do I move?
No,
No, you're gonna. Well, thank you, Justin, and Happy New Year to all our viewers. It looks like the message has got round the Czech Republic and the UK and to Germany. Happy New Year to Merrick, Zednik, Charlie.
Derek.
Oh, Derek's there as well.
6DZ, yeah. 3HZ, David.
David, 3HZ.
DL8HCZ.
DL8HCZ, that'll be Joe.
David VK5KK.
David 5KK.
Merrick.
Merrick.
OK2AQ.
OK, yes.
OK1 DFC.
The Zednik, yes. And I guess we probably must have Vlada and Tonda there as well somewhere, seeing that the message has got around the Czech Republic. So, we will proceed. Not often that within 1 week one gets 2 world records. We'll start off with the 24 gig EME work. And this was on the 31st of December UTC time, but in fact it was 2015, early in the morning in VK, but still 2014 for the Czech Republic and for the UK. In this case, here's a map of Tasmania. And we can see down here Mount Wellington, where the previous world record was set between myself, VK7MO, and Charlie and Petra back in April last year. Mount Wellington's up about 1270 metres, and by going up Mount Wellington we reduced the absorption loss and saved ourselves about 2 dB, which was necessary to achieve a QSO. But since then, we've both increased our power by 3 dB, so we should be able to work from sea level. And we've moved down to this spot, this little triangle here, which is about as far as you can get from the UK and still be in Australia. In fact, if you go any further, you'd have to go to New Zealand, and I think the absorption would kill everything on 24 gigs if you did that. So this extended the record by about 60 kilometres. We had been looking at options of trying this for about the last 3 months. Every 3 months the common window opens up between the UK and Australia, but we also needed situations where there was low precipitable water, low moisture content in the atmosphere in both the UK and Australia, no cloud, and no rain. The first 3 times we tried, well, we had planned things, it just wasn't going to work because at one or other end we had poor conditions. Finally, on the 31st of December, it looked like it was worth a try. So I had picked out a site right down the southwest of Tasmania, which is all forested, but fortunately this little spot round here had been cleared, and there was a a reasonable takeoff down to about 2 degrees on the horizon. So that was about the only promising spot. I was here in this little clearing, and there's all this tall timber behind me, but fortunately, if we look in front, all this had been cleared just for our 24 gig contact. I actually operated from about here, just in front of this low stuff, and that gave me about 2 degrees to the mountains here. This particular photo was taken during my reconnaissance trip, and it was all cloudy that day, and that wouldn't have worked. For planning these 24 gig EME exercises, what we do is we try and take account of the amount of precipitable water at both ends, the degradation, the additional loss for the moon being either as close to the Earth or further away, which can be up to 2.5 dB. And we also take account of the losses due to the libration spreading. And at 24 gigs, libration spreading can be up to a couple of hundred hertz, which mitigates against the use of narrow bandwidth modes. So when we combine all these factors, this red and yellow, there's actually a red and a yellow line, but it looks all red on here, is a measure of the total extra losses, and they're all around here. They're about 12 dB, or no, 11 dB, and this green line is 13 dB, and we've established that we can actually operate with total extra losses up to 13 dB. So potentially it was possible over this full period, but we also need high elevations at both ends. Well, by high I mean more than about 8 degrees, so that we don't go through too much atmosphere. And so the elevation controls the period over which the absorption is low enough to get through. So these sawtooths establish, the peak of the sawtooth establishes the time in minutes that's potentially available when the signal is below the reference, or that the losses are below the reference. So it looked potentially like the 31st of December, we might have up to about 58 minutes. Now that was subject to only having 15 millimetres of precipitable water at both ends, no cloud and no rain at either end. Precipitable water is in fact a measure, if you were to condense all the water above you down into liquid water, you would get a number like 15 millimetres, which is not a lot. Very good conditions, it'll get down to about 5 millimetres. Round here it's often up to 30 millimetres. If you W5 LDUA in Texas, it gets up to 40 and 50 millimetres. So 31 December was the best time, but any time from about the 29th through to about the 3rd of January would have been worth doing, providing when it got to the day there was no cloud, no rain, either here or the UK or the Czech Republic. As it turned out, the 31st seemed like the best day to try. And if we compare the losses, the total extra losses between Mount Wellington and the Tasman Peninsula, when I went up Mount Wellington, we had 9.6 dB of total extra losses. Down on the Tasman Peninsula, it was 2 dB worse at 11.6 dB. But we've got 3 dB more power, so we should have been 1 dB in front, and that should have made it work. The way I got the 3 dB more power at my end is I phased up 2 of the DB6 and 2 10 watt PAs. They are the same as what OK1KIR uses, and I used Magic T's for the phasing, which were tuned up by Charlie, sent over to the UK, tuned up, arrived back here, and all worked.
No, there's a service for you.
Yes. Now, the moon rose in the Czech Republic before the UK, so we started off listening for OK1KIR. Initially I could see quite good signals on the waterfall, but I couldn't get a useful sync. And that turned out to be because their timing was out, and when they shifted their timing by 1.5 seconds, it immediately decoded, and I picked up that they were sending me a -16 report, quickly responded with the Roger -15, received an RRR, sent 73, and within about 4 or 5 overs, 5 minutes, that was complete, and that gave OK1KIR a new OK distance record for the Czech Republic. Then went over to work Charlie G3 Whiskey Delta Golf with Petra. They work in tandem, which helps a lot. I haven't got a Petra that helps me out in the bush on the Tasman Peninsula. Fairly soon I saw a 1270Hz tone, and then I transmit, well, it says there 1500Hz. I would have transmitted, actually changed that to 1000Hz, which means please send messages. You'll notice the timing is much better from Charlie and Petra, sitting at around 2.3 seconds, which is the correct time to get a signal to the moon and back. And I needed to average these two periods, so an average of 2, and I got a decode from Charlie with his grid locator of IO92. Then Charlie came back with a -18 report. I responded with R-17, which I picked up, I transmitted a -18 report. Charlie responded with R-17, which I picked up in a single line, didn't need averaging, which showed that conditions were fairly good. And there was no cloud at my end, no cloud at Charlie's end. So we're very lucky. I quickly sent RRR as a single tone and received a single tone 73 for a new 24 gig world record, extending the previous record by about 68 kilometres.
Woohoo!
So thank you to the OK1KIR team and G3 Whiskey Delta Golf team. That was a real New Year's Eve treat.
Definitely. And then you had the fireworks.
Didn't notice any fireworks in the Tasman Peninsula. It was perfectly quiet. I just went to bed then and slept in the car.
Okay.
No, a day or two later, it looked like from the Hepburn charts that it might have been possible to work across to Western Australia on 10 gigs terrestrial. So I alerted Derek VK7MO, who's on and listening, to the possibility, and he said, he'd be ready to go. I had taken a 10 gig system over to Derek more than a year ago, and that was a 10-watt system, 60cm dish, and I had my EME dish with 50 watts, my portable EME station in Tasmania. As we watched the Hepburn charts develop, they got worse and worse, and I said to Derek, look, I don't think it's going to work this time. It's not worth the 700-kilometre round trip from Hobart. But by the Monday morning, I noticed the VK3s are from here, were working into Western Australia on 2 metres. And I thought, damn, I should have gone. So I rang up Derek and I said, look, I think I'd like to try, but it's going to take me an hour to pack and another 4 hours to drive up there. It turned out it took me 2 hours to pack and 5 hours to drive up there. 350 kilometres on rough dirt roads for some of the way you don't do in 4 hours. And when I was halfway there, Derek sent me a text message to say he was ready to go, and he was transmitting. So I had to respond and say, sorry, I'm going to be a bit later. Now this path is almost a clear water path right across the Great Australian Bight. There is a little island here called Hunter Island, but it's quite a low island and it only gets to 57 metres. So I was hopeful that wouldn't stop the signals on the water path. And the plan was to try this 2,732 kilometres, which was just slightly longer than the previous world record set in Europe, which was actually set from the south of Portugal down to the Cape Verde Islands by D44TX. I've never heard of a call sign like that. 4TX, but maybe the Cape Verde Islands have call signs like that. And CT7F6DPH.
Oh, that's French.
That's right. We know what F calls are,
Yeah,
but
yeah.
we don't know what D44TXs are in VK. So it was possible to exceed that by about 30 kilometres if we could do it. And we'd been planning this for about 2 years since this European record was first printed up in Durbus. Now there had been some very good work done a lot earlier in VK. Wally House, VK6KZ, had worked Roger Bowman, VK5NY, over 1,912 kilometres, which was the world record back in 1994, using this Great Australian Bight. And when I had returned last year from helping Derek set up, I had worked him from Port Campbell over 2,293 kilometres, which wasn't a world record, but it was certainly an Australian record.
Rex, the Wally House record, that would have been sideband, wouldn't it?
The Wally House was sideband, and this one was only JT4.
Okay.
Not only was it sideband, they only had 100 milliwatts and a 40cm dish, and I worked out that with the increased sensitivity of JT4, the 50 watts I was running, and the size of the dishes at both ends, I was about 45 dB up on what that record was in 1994.
You could have gone to New Zealand.
So, up at Cape Portland, which is where I was operating from, there is a wind farm and a sign here that says trespassers prosecuted, don't go anywhere near that, getting over that fence. But I set up outside the fence, and Oh, wrong way. This little red line here is the correct direction for Derek, 2,700 kilometres away. I had previously plotted this wind farm tower, or windmill, as a reference, and I knew I needed to move 1.5 degrees away from that. Fortunately, they provide these references for us.
Definitely. That are visible on Google Earth.
That's right. I forgot to take a photo of my system when it was light, so this was a photo after I'd finished everything and it got dark. Now, this is what the Hepburn chart looked like about an hour before the QSO. And here's the path to me. It's not exceptionally good. It certainly goes over a very nice bright orange bit there, and a little bit of yellow and green. Then it almost gets down to blue, and sort of green and yellow, but I didn't think that would work. Now the VK3s were working into to Derek on 2 metres, but of course they had a better path, and I think the VK5s were also working across. The difference between these 3 paths, that's my path, that bottom path. Colin, VK5DK, is at Mount Gambier, and his path at least crossed a brighter yellow path and stayed in the green. And one would have thought VK5KK, David, in just south of Adelaide, would have had the best signals right through here. As it turned out, Colin had the best signals.
Moral of the story, don't believe Hepburn all the time.
Yeah. This is what the mean sea level pressure analysis showed. There was a low pressure trough coming in here, and once that trough passes Derek, that's the end of the signals. So we were right on the margin. Derek actually found there were 2 maps which had different lines, and one of them was going to happen before I arrived, and the other a few hours after I arrived. So the second one must have been the right one. And of course there was another front here which had to get past me. So potentially we were just between the trough and the front, and this front was low enough out of the way. So they are all indicators that it might have worked. Unfortunately, our Bureau of Meteorology in Australia works for the government, and our government takes money away from everybody at the moment, and they don't do all the radios on flights that I need. They didn't do one on the 5th, but Esperance, which is the sort of closest one I could get along the path, Adelaide and Melbourne were too far away. Mount Gambier, they seem to have closed down. Euclid, they've closed down. So I plotted up the refractive index data from the radiosonde, and you'll see here the refractive index. If the refractive index gets more negative than that dotted line, it's sufficient for ducting, and it gets much further down than that dotted line. So this was a very strong duct, at least over in Western Australia. What it was at our end, I don't know, and even if the radiosondes were all working, they don't actually have any in the middle of the water, so it's a bit hard to get a clear view, but I think the Esperance data does at least tell us that there was, at least for part of the way, an extraordinarily strong duct. Now, when I got up there, I was already 2 hours behind the schedule that I was supposed to be. and I rang Derek and said, I'm I'm about ready. What I had forgotten is that I had only just turned on my GPS, which had been off for about 5 days, and so it needed time to lock up properly. But I didn't think about that at the time, and within about a minute of my ringing Derek, I saw a tiny, weak, little 1270 Hertz tone. It's probably very hard for you to see, but there is something just about there. And when it was integrated using the yellow graph feature of JT4, I got this lovely spike. Unfortunately, it was 40 Hertz low, and I thought, oh dear, this can't be right. I know Derek and I are always within a couple of Hertz. It was only later that I realised that my GPS was probably not on frequency. So I was a little... What?
Just turn it down towards you, Rex.
Right. So I was a little worried that whether this was a real signal or not, but it was enough to encourage me. And then for the next half hour, I saw absolutely nothing. And I thought, damn it, if I'd have got up 2 hours earlier, it would have worked. However, I started to see 4 little tones. There's 4 little tones here. They're very hard to see, but there's 4 little tones. And you can see here that I was getting a hash and a fairly stable frequency, minus 13 Hertz, minus 11 Hertz and minus 9 Hertz. My GPS is obviously a lot closer now, but it's still drifted from 13 Hertz to 11 Hertz to 9 Hertz. And the DT is also accurate, 0.3 of a second, 0.3 of a second and 0.4 of a second. And signal levels have improved, minus 20, minus 18 and then minus 16. Well, at minus 16 I actually got a decode from Derek, who probably was copying me earlier because I was running 50 watts compared to his 10. And well, once you start getting that, life is looking terrific. A little bit later, I sent a Roger and a minus 16 report in response, and immediately I got a very strong little tone here, almost on the red line, still a fraction low in frequency. The red line represents RRR, Roger, 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 and Roger, Roger, Roger means you've completed a QSO. So, joy, joy, a new world 10 gigs record. But we wanted to do it on SSB as well, so we waited, watching JT4 for the signals to improve. Occasionally I could hear JT4, but was always just on little peaks of QSB and so forth. But ultimately, this is the full JT4 QSO where I received the RRR on the report waterfall, and we finally got through on tiny little QSB peaks on SSB. I gave Derek 3 and 1, he gave me 5 and 1, but given that the power difference, I had 50 watts and he had 10, that is not surprising. So we were very much right on the limit for SSB. A fairly good signal on JT4. In fact, there were times when I actually got him down to minus 12 on JT4. JT4 tends to saturate at minus 12, so it was probably quite a bit better than that. And given that we actually got through, you know, with single line decodes and potentially -12, if you used averaging, you could pick up, well, probably 8 or 10 dB if you were struggling to complete a QSO. So I think in terms of JT4, we probably had 8 to 10 dB to spare. In terms of SSB, we had nothing to spare, but that's basically the difference between JT4 and SSB. Okay, so my conclusions are: 1, you need a lot of luck. You've got to have the Hepburn thing all right. You've got to get there in time. And I guess you've got to take advantage of, even if there's a remote opportunity, you've got to go, even that's going to cost you a 700-kilometre round trip. There's been a lot of planning behind this. In fact, I first started doing this 2.5, 3 years ago with the aim of going to Western Australia and spending a couple of weeks over there and working back to Joe 7JG in Tasmania. But a couple of weeks is just not enough time to get good conditions, and it was obvious that I had to have a permanent station. And while I was there, I was talking to Derek, and he was very pleased to be involved. And so the next year I travelled again to Western Australia. I don't do these trips for nothing in Western Australia. I do spend a lot of time doing EME on 10 gigs and grid squares for different people who need them. But from Tassie to Western Australia and back again, well, by the time you do a few other things, it's a good 6,000 kilometres. So a second trip where I set Derek up and travelled all around doing tropo tests with him, so he could learn the ropes of JT4, and Derek picked it up very rapidly, and suddenly got, after a couple of weeks about over there, he got about 25 grid squares. You certainly need reliable and proven equipment both ends, and that means portable operations. I learned a few things from my father, which was, when you're going portable, you put spring washers on every nut and bolt. You make things light and flexible so that vibration doesn't... He was a ham, by the way, and I followed all his principles. He's not with us anymore, but he'd be very proud of my following his principles. There's been a lot of experimentation and testing to understand this, introduce GPS locking, developing of the digital modes in conjunction with K1JT. I should say the spreading on this occasion would have been narrow enough to allow us to use JT65, which is slightly more sensitive. But we have found generally on these long paths you do get spreading due to the I guess the path length's changing because the height of the duct's varying, and that does spread the signal. And once you get any sort of spreading, you're much better off to use JT4 than JT65. The other thing I've done is, throughout all these tests, and the OK group will understand this as well as the G group, I rigorously write up everything we learn and all the results and the conditions, which has been essential to understanding what's involved. And the other thing, you need similarly dedicated people at the other end, and I've listed all the people who've been at the other end to make this all possible. Charlie, Petra, Vlada, Tonda, I should say Mirik on on 10 gigs, LW5LUA, Derek 60Z, and David VK3HZ. Thank you all who've made all this possible. So with that, I'll conclude the talk, and if there are any questions either on the repeater or on the streaming site, I will try and answer them.
There is one comment from Joe DL8H.
Right.
For your information, you better don't use straight lines for the long east-west paths on the Hepburn maps due to the kinds of projections of the map. If you find you need to use slightly curved path lines, which may shift centre path sections in areas with other colours.
Right. Well, thank you, Joe. That's very useful information. Have you got some mechanism by which I can adjust the paths to be correct on the Hepburn projection? And I wonder how far out they would have been. And that might explain some of the reasons why...
It worked.
Well, we had the odd signal report, stronger signals from 5DK than 5KK. But I suspect that while the projection would make a difference, it probably wouldn't have made that big a difference. But perhaps Joe might be able to tell us, about how many miles or kilometres of bend on a 2,500 kilometre path, which is east-west.
Joe also made the comment that D4 for TXV, the original,
yes,
was actually a HB9.
Okay, so that was a HB9 portable who presumably had to apply for and get a call sign from the Cape Verde Islands, and that was that, right.
Okay, one question. What I assume that's minimum watts do you use for tropo, please?
I don't use minimum watts, I use all the watts I've got. Now, Derek was running 10 watts. I was running 50. 5KK, I think, he'll be able to answer this, is probably running one of the new 5 watt DP6NT amps. And Colin 5DK was running 7 watts. So, who asked the question?
I'm not sure.
That was Joe, was it?
No, I'm actually not sure.
Oh, okay. So, essentially, 5DK actually had signal reports of 5 and 7, 5 and 2 over, I think, about 2,100 kilometres, and they were running 10 watts and 7 watts. But if I've got that wrong, Colin can put an answer.
Okay. David 3HZ says the VK logger history should show the curved path. Joe's come back with the difference is a few hundred kilometres shift in the path centre on a 3,000 kilometre path.
Wow. Well, a few hundred kilometres would certainly change things significantly. So thank you for Joe for that. That's something we will have to take into account.
Min W is a special term. That's the person.
Yes, I know what the term means. Who's asking the question?
No, I don't know. Same person as... Oh no, sorry, different person. And I don't know who it is.
Okay, what's the question about?
Well, Min W is a special term. It's just a statement, I think.
Yeah, the Min W we're using on EME. I think I was using Min W of C for Charlie on EME. The effective spreading was about 90 hertz, which would be, you'd start about C. admittedly I started off using min-W of C on the path across to Western Australia on the Tropo path, until I realised that I really should reset it from EME. But my first Tropo decode was at min-W of C, and when I realised the spreading was very narrow, I actually changed it to A. I'm still a bit suspicious about using A, because I've found that sometimes you do worse on A than you do on B, even on narrowly spread signals. I think I would recommend to people that if on narrow signals for Tropo, that you use min-W of B for Bravo. Okay.
That's it from the questions online. What about questions
On VHF?
RF? Yeah.
Okay, this is VK7OTC. For purpose of identification, we've run over. Apologies to the ASMO. Any questions from our VHF audience? No.
VK7OTC, VK7TL, good evening Rex and all. No questions, but just a very big thank you indeed for a marvellous series. I have to admit I was mucking around with HF antennas in the backyard, so I only caught the last 10 minutes, but no, very interesting indeed, and well done. I think, was it yet another world record, I think, is under your belt, so you're running out of wall space for the plaques, I think. But anyway, no, that was a very interesting series indeed, Rex, so thanks once again. I don't know if Charles is there. I have given him a PVR, which may or may not be working, so we'll see if he's there. But thanks again, Rex. VK7OTC, VK7TL.
V7PP. Charles, go ahead.
Derek says he was using min-W of A.
Okay. Charles, did you have a comment? No. Okay, and Derek reports that he was using min-W as A, which is what you'd sensibly do with such a narrow signal. So that all makes sense. Any more?
V7OTC, VK7RM.
No, that's Ron.
Ron, go ahead, Ron.
Thanks, Rex. Hang on. I was turning the volume down. It was getting through the TV. Thanks for a good talk, Rex. And congratulations on the record. VK7OTC, VK7RM.
Thank you, Ron. Okay, that seems to be all the questions on VHF, and we've covered all the questions
Off, streaming.
And, well, thank you again for all of the European stations that have come up and listened to the talk. It all makes it worthwhile going to the effort of producing it. Thank you all. We've now got a couple of other talks, but whether the European stations want to be involved in that, we'll leave it to them, but I will now hand over to is it Steve next?
Yep.
Or
Yep.
to Steve. 700.